All right, so just to do a little bit of a recap, we checked out how to do simple operations in R. We learned about the modulus operator, that it gets you the residual of an integer division. We learned how to assign variables and what is a shortcut to make these two symbols just at once, which was Alt and dash. Gotta put my keyboard in English. Alt and dash. We checked out the different types of variables that there are: logical, numericals, and characters. It's being recorded. And then we introduce vectors. So vectors are basically an aggregation of different entries of either logicals, characters, or numericals. We saw how to subset the individual vectors. We saw how to name the vectors. We saw how to check some operations with set vectors. And we rounded up on that we were going to introduce matrices. So remember, to create a vector, what we had to do was use the concatenate operator, which is the C function. And inside you can put anything you want, given that is the same type of variable. So let's say 1 through 4 creates me an integer vector of 4 elements of 1 through 4. I could have done the same thing without the C, because R already recognizes that this is a string of several numbers, so entries for a numerical vector, and I get the same result. So we were going to check matrices. So matrices, how do we create matrices? We use the function matrix. So the function matrix, if you want to look up the help of any function, you do the question mark and the name of the function. So matrix takes the first argument as a data, then the number of rows, the number of columns, and I'm going to explain these two in a few. So the data that we want is a vector of 1 through 9. However, this vector, how do we want to dimension it in a matrix? So in this case, I'm going to say that it's going to be 3 rows. Now this by row, what it's telling R is saying, I want 3 rows. Get me these 9 data points into 3 rows, and you get the job of calculating how many columns you got to use for that. Now, 9 items, 3 rows, that means 3 columns. So I get a 3 by 3 matrix. I could have done the same just by saying it only needs 3 columns. So it will calculate on its own that it needs as well 3 rows. I could be extremely specific and tell R that I want 3 rows and 3 columns. In all of the cases, I have a matrix. Let's do some examples. Now, I hope somebody is a fan of Star Wars, because the whole example for matrices are for Star Wars. So this is the box office results in millions of dollars on that time, because inflation has gone up. I believe this is 2014 data. For the first 3 movies of Star Wars. Now you can realize those are 3 vectors of 2 entries each. Now, what do both entries mean? Now, one is what the movie grossed onshore, and one is what the movie grossed offshore. So basically, how many money did they make selling tickets on the US and outside the US? We're gonna combine them by using the function concatenate. So if I have 3 vectors of 2 data points each, I'm gonna get a vector of 6 entries. If I have a vector of 6 entries and I input it into a matrix, and I tell R that I want 3 rows, I divide 6 by 3, so I get 2 columns. This is my matrix now. However, just by looking at this thing, we don't know what any single row or what any single column means. Let's give it a little bit more data. So remember, for the vectors, so by row is telling R that with the number of rows that I want, R, please calculate the number of columns that you need. I'm not going to give you the number of columns that you need. You do it yourself. That's what by row is telling R. So if we want to give it a little bit more information, just like vectors that we use the names function, a matrix has more than one dimension. It has 2 dimensions. So there are 2 functions. Now, one is col names, so column names, and one is row names, so row names. So the region will be my column, and the titles for each movie will be my rows. I apply them each respectively, and thus I have a new matrix. A matrix that is now understandable. So I now know that the first row is telling me information about A New Hope. Meanwhile, the first column is telling me how much the movie made in the US, and the second column is telling me how much the movie made outside the US. All good? So let's say I want to know how much the movie made on each kind, per how much the movie made overall, worldwide. So there's a function, like in vectors, we saw the function sum. If we had sum 1 through 6 is 1 plus 2 plus 3 plus 4 plus 5 plus 6. In the case of row sums, it's going to give me a result per row. So in this case, it's going to sum 460 with 314, 290 with 246, 247, and 309 with 165. I have the results per movie on how much it grossed worldwide. If I want to get this column into, or this vector into my matrix to be part of a third column, I can use the function cbind. Cbind, what it does is I have my matrix and I want to add to the side more data. It has to, my new data needs to have the same number of items as my rows. So this one has 3 items. I have 3 rows. So I can easily cbind it. By doing the cbind, I now have 3 columns. Now my 3 columns tell me more information. It's basically the sum of these 2 items yields the. All good so far? Okay, let's go to the next one. So just like there's cbind, there's also row bind. So I'm going to load up a new matrix. Now my new matrix is called Star Wars Matrix 2. This is just some data that I loaded up, and these are the rest of the other 3 movies. I will upload this. It's already uploaded. It is already uploaded. Yes. So, so where was I? Row bind. Yeah. So I'm gonna load a matrix in which I have the rest of the other 3 movies, so the prequels of Star Wars. Now this is the movie that came out in 2002, one that we saw when we were little, and I want to add these 2 matrices. So you have one matrix on the top and one matrix on the bottom. The way to add them, they need to have the same number of columns. So Star Wars Matrix, sorry, Star Wars Matrix has 2 columns, and Star Wars Matrix 2 has 2 columns as well. That way we can add them together with rbind. So we have one on top and one on the bottom. If we execute this line, we get all Star Wars Matrix, and we have all the movies, pre the sequels, with how much money they made on the US and how much money they made outside the US. Just like there was a function to do row sums and thus allowed us to know how much a movie grossed worldwide, so US plus non-US, there's a way of knowing how much all Star Wars movies made on the US and how much they made outside the US. Instead of doing the row sums, we are going to do the column sums by using col sums. If we execute this line, we're gonna get that the gross number per US, so per region in the US and outside the US are the following. Just like we subsetted vectors, we can subset matrices. Now the difference is that we don't have just one dimension anymore. We have two. So in order to specify to R which function, which dimension we are trying to use, we use this comma. So for starters, I have my all words matrix. If I want the first row and the first column, I'm gonna do 1, 1. That is 461, which is A New Hope in the US. If I want all the rows, but just the second column, I can do this. The non-US revenue for all movies. Now, on average, how much did a Star Wars movie gross outside the US? I can do the mean of the vector I just created. So on average, outside the US, any Star Wars movie made $348 million. So just like vectors again, I can select more than one item. If I want just the first two movies outside the US, I can do this. So outside the US, the first two movies grossed on average 281. So we can safely say that in time, movies have made more per release. Now, let's say, for example, we wanted to know how many people went to see these movies. Now, on average, now this is a very rough average. A ticket for the movies costs $5. So if we divide these numbers in between 5, we can get the number of tickets that they've been sold. So we can estimate the number of visitors that have seen Star Wars movies. So if we take our Star Wars matrix and we divide it by 5, we can estimate, now this is a rough estimate, that for example, 92 million people saw A New Hope in the US, and for example, 110 million people saw The Phantom Menace outside the US. Any questions so far? Go ahead, Alvaro.
Excuse me, I have a question about the line 337 that you put
37, okay.
known as all. Yeah, when you put all wars matrix comma to what it means is a column where you are creating or
It,
a
what you're
vector column.
creating is another matrix. And they say it transforms it into a vector because it only has one dimension. So what the nothing comma 2 is telling R is grab me all the rows, but just the second column. So by grabbing just the second column, you effectively have one dimension. A
Okay.
vector of 1 times 6.
So this is all a column. Also, it's just a vector
The
column.
entire second column, yes.
But it's like but it's put into columns when you write it in the console. These
How
are the
come?
two. are two columns. That's why I get
Oh
very
no, it's a
confused.
way of printing it. So for example, if I do this and I print it like that,
Ah, okay, okay.
yeah,
Thank you.
it's just because the space constraint.
Okay, okay. Thank you.
Yeah, don't worry. Is visitors a matrix is itself or is it a view? It is a matrix itself. So if we check visitors, we can see, and if we use the remember, we learned two functions. So one was class. Class is telling me that it is a matrix. Now I'm going to teach you another function. Now str means a structure. If we run str on visitors, it tells me the structure of my object. So my object is filled with numerical values. It has 6 rows and 2 columns. Now they do have some special attributes. Now the first one is that the columns, I mean the rows are named and also the columns are named. Alvaro, do you have another question? Because you still have the raised arm. str shows you the structure of an object. It includes the labels because they are attributes of the object. When creating a new object, they follow the structures of the previous one used for its calculations. That it is. That is correct. What do you call an object? Everything that is on my environment tab is an object. It can be part of data, it can be part of values, but all of them are objects. In fact, what we can see over here is a global environment. There are also hidden environments. So, for example, if I write letters over here, letters is an object that outputs the whole alphabet on um, on non-capital letters. However, if we read over here on the left on my environment tab, letters is nowhere to be found. There are hidden environments that we can traverse over here. In this case, letters should be on the base environment over here, letters. So there are a lot of hidden functions and data points in R that you cannot see, and you will get to know if you keep using it. I hope that was clear, Alvaro. Very well. So we're going to skip factors and are going to go straight to data frames. So data frames. Another variable that's hidden. So I'm going to clean my environment just for cleanness sake. So in order to clean your environment, you can use this broom over here and click yes. If you want to clear your console, you can click this grayed out broom over here, or use the shortcut Control plus L. So there's one very known data frame in order to test stuff that is called empty cars. So empty cars, one is a data frame. Now you can see that it looks very similar to a matrix in which it has rows and it has columns. Now the difference is that data frames can contain different types of data per columns, and they are more flexible. Matrices can only have the one type of data inside their structure. So matrices can only be or numericals or characters or logicals. Data frames have to have actually the same data point per column. And the columns inside of data frames are called variables. So again, we're going to investigate it with str, but first of all, let's see one very useful function to investigate your data frame that is called head. Head shows you the first 6 rows of your data frame. Or you can modify head by giving it a second argument, a comma, for example, 2, and it'll show me just the first 2 rows of my data frame. Now again, let's use str that we used in the matrices. So str of empty cars tells me that I'm using a data frame with 32 observations and 11 variables. So analog to the matrices, this would be 32 rows and 11 columns. Now these 11 variables are the following. All of them in this case numerical, but they could be different. And the names per each are the following. Now you can notice, there's a question. Yes, it is like a set of variables. Now remember, all of the variables inside a data frame need to have the same length, which means that they need to have the same number of observations, because you need a complete picture of your data frame. Now, you notice this dollar symbol. What this means is that we can access, for example, CIL, which is the cylinders of the cars inside the data frame, by doing empty cars, dollar symbol, cylinders. And I can access this vector of data. Now let's do an example with a little of astronomy actually. So I'm gonna get some vectors. Now you can see that I have 2 character vectors, 2 numerical vectors, and a logical vector. And I'm gonna build a data frame with the function data frame using these 5 vectors that I just created. I'm gonna tell R strings as factors equals false. So by default, and this used to be this way. I think they've changed it by now. That by default, character vectors auto convert it into factors. Now we're not gonna see factors right now because of time, but factors are basically masked out character vectors. So for those of you who took eViews, in eViews or in Stata, you had some characters that you could turn into numbers and just have a label for them. That's basically how factors work. And factors are very useful for some kinds of stuff, but right now I don't want any factors. So we're going to create this data frame, and it's going to output the following. So my planets, the type of planets they are, the diameter of the planet, the rotation velocity, and if they have rings or not. If we check out the structure of my data frame, we can see that we have 8 observations and 5 different variables. Now, 2 of them are characters, 2 of them are numericals, and 1 of them is a logical. So, for example, if I wanted to know the first row of planets, so the first planet, and the first 3, or I mean, just a third column, I'm gonna get the first planet, which is Mercury, and the third column, which is its diameter. If I want the fourth planet in all of the data points, I can do 4, nothing. And I get all the data points from Mars. Remember when we named vectors, when we were doing stuff with the poker data and the roulette data? We could use the days of the week in order to subset. Since our variables also have names, we can do the same. So if we want the first 5 planets and only the diameter column, we can do the following and get the diameter column for the first 5 planets. If we want all the rings, so basically the whole column of rings, I can do this and assign it to rings vector. You can see that it's the same if I print it out with the variable or by the operation. Now, remember that we could subset with logicals as well. And when we subset it with logicals, the output is only in the positions in which the logical shows true. So if we have true over here in the last four, we are only going to get the last four planets. Jupiter, Saturn, Uranus, and Neptune. Now, there is another way of doing subsets. So for example, I can say that with the function subset, I want to subset from my data frame of planets the ones in which the diameter is less than 1. And I get the ones in which the diameter is less than 1. Now I can do the same without using the function subset, just by using the brackets that we've been using. So planet CF, in which, and I'm creating by using this a logical vector. So planet CF, dollar symbol diameter, this will give me the diameters. If I say the diameters that are less than 1, I'm going to get a logical vector. Now, if I apply this logical vector as a subset, I'm going to get the ones in which the diameter is less than 1. And you can see that we get the same output with the function subset or by doing it this way. Now, later on the workshop, we're going to see a better way and tidyverse of doing this kind of subsetting. So far, guys, any question? No? Okay. Let's go on into functions. And let me quickly upload the 2 more files into Blackboard. I'm going to upload 3 files. We're not going to see all 3 of them, but they can be useful for you. Also, remember that I uploaded 2 Excel files into Blackboard. We are going to need those 2 for the workshop. Okay, so functions. In order to do a function in R, you have to use the function. So function allows you to explain what you want to use in order when you execute the function called what you put on the left side of function. So for example, I'm going to write, let's clean my environment a bit. I'm going to write my function, which will be a function with no arguments. And what it does is just printing hello. Now, if we save this, you can see in my environment that I have a function called my function, and it doesn't have any arguments. So if I write my function, it's going to print out hello. If I run it again, it's going to print every single time hello. Now, my function name will be the same. However, in this case, I want it to have an argument. Now, the argument is name. I'm going to print. So what paste does is turning 2 elements and put it in a string together. So hello. And let's say, who do we have in the class right now? So Alvaro. it prints out hello Alvaro. So, for example, if we save my function name and we do my function name, let's change it a bit, Fabio, we have hello Fabio. We change the name to somebody else, let's say Carlos, we get hello Carlos. Pretty cool, right? Now, arguments can also have default values. So default values are written in the following way. When you define the argument, you put equals and the value that you want it to be the default. So my function name 2, if I don't write anything in the argument, it's going to assume that I want to put in David. If I write something else, it's going to replace that with that something else. All clear, guys? So that's how arguments work. The space is established. Oh, that's old. Oh no. The space is established by the comma. What do you mean?
I think that for default the comma make an space. You don't have to put with the another parameter the space in the other word like you using um, hello.
Hello, Alvaro. Yeah. So there are two functions. There's space and there's space 0. Now, that the difference in between the two is, like you said, paste already adds as a space in between the two strings. Paste 0 does not. I generally use space 0, for example. I think that was what you were referring about, right? Okay. All right. So there's, for example, this very useful function in Excel that's called sum product. Now, the function doesn't exist just like that in R, so we can write it. So sum prod takes an argument x and an argument y, and it multiplies and it sums the multiplication. For example, we have 1 through 5 and b, that is 10 to the power of 1 through 5. Now, what does that mean? It's 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, and 10 to the power of 5. We can do a sum product of all of them, and we get a number. Now, we can use different functions to analyze a function. Now, body, what it gives me is what it's inside the bracket, so what a function is effectively doing. Formals is going to tell me the arguments it's using. Now, for example, here formals is only telling me that it exists an argument x and an argument y. But if I use it in my function name 2, which remember had name equal to David, it's going to tell me more information because it's going to tell me the default value that name has. And the other one that you'll probably use less is environment. Environment is telling me where is my function being saved right now. So for example, I told you that there was the global environment, that's the one you'll mainly use, but there are also hidden environments over here. Say, for example, the function abbreviate. Abbreviate is not in the global environment, it's in the namespace base. So whenever you load a function whenever you load a package by doing library, it creates its own environment. Now, most of this, from here on below, so 1, 2, 3, 4, 5, 6, 7 packages are loaded by default in R. All of these I have loaded by default in my session. Now, we can also write some what can we say, like user-friendly warnings into our functions. So for example, I can write the function square root. So square root, what it's going to do is doing a number or a vector or any object to the power of 0.5. So this is basically square root. However, if the user that uses my function doesn't give it an x value, so if missing x, then I want to apply and show a warning that argument x is missing. That way the user, I'm sorry, that way the user will know that I'm actually trying to, so what he did wrong basically. So if I do a square root without any argument, one, R is going to give me an error. Now two, I have my warning message. Argument X is missing. We can keep modifying our function. Now we had argument X is missing, but for example, you cannot do a negative value to a square root because you'll get into the complex numbers, and we don't want that. So for example, we can do if any. Now what does any mean? Any basically takes a logical, and if any of the values of the logical are false, any will give you false. If all of them are true, any will give you true. So if true, true, false. Oh, okay, so uh, if any is true, it'll give me true. The contrary would be all. So all needs all of the items to be true in order to be true. This will be false because there is one false. It's like so any is like an infinite or, and all is like an infinite and. Okay, so the same thing would be true and or true or false, or true and false. Are you guys following the logic behind that? I'm gonna take the silence as yes. Alvaro.
Yeah, sure. I have a question. When you define the function of square root,
Mm-hmm.
um, and for example, in line 42, you don't put anything. Uh,
Mm-hmm.
Also, that if you like result that, for example, if argument x is missing, but also
Mm-hmm.
they send you another message, no? But this is the computer, no, no, not you, right?
Yeah, so this first part is R by itself.
Ah, okay, okay, okay. Yeah.
And this one is created by the warning that we created.
Okay. Okay. So can you repeat any? I don't really understand that.
Yeah, so any is basically compounded or. So if you know the or, so in R, how we write or is the same as doing this. No, not this one. This one. So if I do true or false, I'm gonna get true. If I do false or false, I'm gonna get false. If I do false or true, I'm gonna get true, and if I do true or true, I'm gonna get true.
Okay.
So basically, I'm compounding different ors. So it's true or false. In the case of all, it's true and false.
Ah, okay, okay. It's like ant. Yeah,
Yes.
okay. Okay, okay, thank you.
So in this case, if any of the values are less than zero, so if we have any negatives, I'm instead of warning, because warning still runs the function, I'm going to say stop. Stop doesn't run the function any further, and it tells the user a message. Do not use a negative number or vector. If I modify my square root function, now I have three values in my vector of length 3. Now, two of them I could quietly apply a square root function, but one of them I cannot. And since one of them is less than 0, that is enough for any to go over here and say stop. It's going to stop. It's going to error out. It's not no longer going to say warning. Do not use a negative number or vector, which is the message that we wrote over here. Huh. I'm gonna modify this. So this is a cool thing that you guys could do in your own. That it's remember the exercise that we did on the roll of dice. You can simulate it in R and check the fair price for each roll, for each number of rolls that you could do. So remember, the first one, for example, so roll 1 was 3.5, roll 2 was 425, and so on. It could be a neat exercise so you guys can practice this. All right. Okay. Okay. Do I get into here or do we have time for the other one? Yes, Alvaro.
Sure. Only for remember that when you roll the dice in the second time because you get less than 3.5, uh,
Correct.
you don't count the I would say en español, la lanzada no la cuentas hasta que te
Mm-hmm.
salga un número mayor a 4.25, ¿no? O lo
Not
que fuera.
really. So what we were calculating were expected values. So imagine that you play the game millions of times. What is the average of how much you would get? So if you were just going to play the game, say for example, and we can simulate that really quickly. So for example, sample will give us the roll of a die. So like this, we're rolling a fair dice. So let's say that you rolled 4.
Okay. Hmm.
4 is greater than 3.5.
Yeah, I stop, right?
So exactly a risk neutral person would stop there,
Okay.
and that's your payoff. That's what you get.
Hmm.
Now, if you didn't roll 4, let's do another example. That game ended there.
Hmm.
You rolled 1.
Okay.
Now you know that the expected value of one roll of a die is 3.5. So a risk neutral person would roll again. So you take the chance and you roll again, and you roll 4.
Hmm.
A risk neutral person, would he roll again?
No, because
Exactly, because it's more than 3.5. So you're happy already.
okay, yeah, okay, okay. But when you add the three numbers higher, what was the point? I didn't understand. You count, you don't count. That's I don't get it.
We count.
Yeah, the second time when you throw the dice,
Mm-hmm.
you only count
You get
the
that 4, and that's your payoff.
yeah, but okay, but you count 4, 5, and 6. I remember, and you get
Yes,
a mean of 5 and times
correct.
50%, right? That thing is
Mhm.
what I don't understand.
Okay, maybe I'm not going to leave it at for home, and let's explore how it looks in R right now. Hold on, let me prop up a file. Assignments, dice roll, and payoff. Mm, which one was good? I think this one was good. Oh, I have a way of knowing which one was better. Hold on. Just a second. Okay, it's either this one or the other one. Yeah, this one was a fun one. Okay, let's see. So, for example, what I told the my previous student to do in the last semester was to do a dice that could have a dynamic number of of faces. So instead of 6, they could have maybe 50 faces or 100 faces or 10,000 faces, and to get the expected value of each one, depending on how many rolls you can do. On this one example, I'm going to paste out the other example over here. Okay. So what they did is basically they have a dice in which you have one towards the max value. In this case, we're using 6. Now the roll is basically just from that set of numbers, get one number. You're gonna get your payoff, and you're gonna get your results. So basically, you have so if it's your first roll, uh, let me see how I can read this out to you. Okay, so if it's your first roll, you're going to create a vector in which you are going to fail with your first roll and your maximum roll so far. Is that it? Yes. And then you're gonna get your payoff and the mean of your payoff. Else, I haven't taught you S supply yet though. Let's see the other one. Yeah, this one is a little bit more understanding. Okay, so we have a roll function, which is basically this thing, sample 1 through 6, just one value. Now the difference is that we could have done we could have done sample 1 through the max possible value that you can get in your die, just one value. Now it says max value, it says 0 because I don't have any object saying what max value is right now. Now this function, what it's telling you is that you're going to throw from your max value all the way to 1. So he's going on reverse. Now, only if your max value is is more than the limit of the number of throws that you can of number of rolls that you can do, you're going to keep playing this game. Okay. So for example, how what is the average of the values that could go above the maximum fair value that you're on. So with 3.5, you have the rest of the set of the numbers, which are 4, 5, and 6. So this function, what it gets is gets you the average of four. Why is it getting 6 though? Oh, of the row 5. Okay, so with the row 5, the only thing that you have elsewhere, so a limit of 5 rows, the maximum number that you can strive for is 6. And this one is what gets you the fair price. So basically, you have your expected value. If you don't throw any dice, your expected value is 0, right? Then you wanna get your two numbers. So if you remember in the tutorial, let me change to that really quickly. Where is it? Here. In the tutorial, we had two components, right? In the tutorial, we had the first component. You can see the screen, right? Yeah. So the first component is what was your the expected value in the roll before. So what is the stream of possibilities that you stay and then throw again? Now, if you want to throw again, what is the stream of possibilities that you have? In this case, it's the expected value of the set that you have left. What it's doing in this code is basically the same. So you're getting, hold on, there you go. Yeah, what you're getting is so this one divided by value basically gets you the average of that set of numbers that you strive for. And this is the residual. So number 1 divided by val. Álvaro?
Yes, that was my question.
Mm-hmm.
It's like you're throwing a dice, and only this die has three values, or is like uh, you throw the dice, but if it's not, eh, voy a decir en español, ya, si no es más de cuatro, entonces no lo cuentas y sigues tirando hasta que te salga de 4 a 6.
It's not any of the two, actually. So it's more towards the first one. So basically, it's not that it doesn't count. It's that you're only counting the events in which people kept playing. In the other events, people didn't keep playing and they stayed with their previous role. So if you want to get the expected value of the game, you have to take into account both of the scenarios. I think with
Uh,
that clear.
okay. It's like if I throw another time and it's less than 4, I just stay with
Exactly.
the first throwing of dice. I don't
Exactly.
throw it again. It's just like I stop in the step. I stay in
That
step
is
one.
correct.
Okay, understand.
Yeah, sorry that we went into a deviation with this one. I'm glad it's clear. All right. So let's go to a workshop now. So I uploaded two Excel files, guys. Yeah, I think it's two. Yeah, one is called spending, and the other one is called superheroes. Let me open the Excel file myself. Tutorials workshop. So I might get spending. And I'm gonna show my screen divided. Okay, let me change it to share the whole screen, and you guys will be able to see my whole screen. Okay, there you should be able to see my whole screen. So R and Excel at the same time. Is that it? Are we good? Yeah, let me bring this to my other screen so I can see what you guys are typing. Okay? So I can see the chat over here. Yes. That is true, Juan Manuel. It depends if how risk averse is the person. So in our example, we're taking a risk neutral individual. So that means he is fine with the fair value. Now, a risk averse person can even take something lower than the fair value because his utility leads him that way. A risk over wants something higher than the fair value. Okay, let's prop this up. So we're going to do, so the general idea of this workshop is doing something that you're used to do in Excel, but doing it in R. So for example, we have some dates over here, some names of months that don't actually have have dates. They have just the word. So January, February, March, etc. If we wanted to get in Excel which quarter this month belongs to, we would need to write a nested if statement. It's basically if or January, February, March, then Q1. If April, May, June, then Q2. July, August, September, Q3. October, November, December, Q4. If it's something else, then give me an A. All right. Let me change something very, very quickly. Languages and setting. Yeah. English, USA. There we go. Let me reopen quickly Excel. I have to change my point comma to regular comma. So this should work now. Yes. This is quarter. And we can fill this out. So this is Q1, Q2, Q3, Q1, etc. But this is really kind of obnoxious to think about, right? In R, first of all, in get new functions, we have to load packages. How do we load packages? With the function library. You use the function library and the name of the package. Now, if you do not have the package, you have to do this one, which is install packages and the name of the package. In this case, the package is tidyverse. Now, tidyverse is a really useful package because it's an aggregation of different packages all at the same time, and all of them are very useful. Now, read Excel is a package that helps us reading Excel files. I'm going to load these packages by using the function library, and then I can use the functions that come from these packages. Now I'm going to read Excel and give it the path on my machine. So in your PC, it might differ to the file pending, which is the Excel file that I have open right now. If I do this, and R already grabs the data from the Excel file. So I have the same columns: month, expense, amount, number of expenses, and budget. All right. And there is something really important over here. The way it's displaying this data is not a data frame, it's a table. A table is a special type of tidyverse data frame that's a little bit more flexible and better to work with. Now, in order to understand why it's better to work with it, we'll go throughout the workshop. Now, in order to use functions with tables, you can do something that data frame not always allows you to do so. So imagine I have a question. Hold on. Headlines. Yeah, so it auto detects that the first row is the name of the variables. Yes. So basically, if we wanted to replicate this behavior of the quarters of the nested if inside R, there is the case when function. However, before going there, I'm gonna give you a little bit of an introduction of this operator, which is the Magrider operator. So Magrider operator, also known as the pipe operator, just written like this, the other way around, written like this, allows you to run functions in a different order. So imagine that we have spending and we have month, right? Month gives you the months of data frame. Now, if we know how how many objects, how long is this vector, we could use the function length. That's telling me that it has 48 observations. Now, another way of doing it is doing this. Using the Magrider operator, we can do month, Magrider operator, length. That gives me 48. Now, what the Magrider operator does is assuming that you want whatever is on its left as the first argument on the function on the right. It can get more useful. For example, spending, I want to filter the ones that month is equal to January, and then I want to know how many in row. It's telling me number of rows, how many they are. So I have 4 observations in January. Can get better. So for example, I want only the January observations, and I want to know what is the. Now let's keep this for later. This is how the Magrider operator works. If we wanted to replicate this nested if, we can do pipe operator mutate. What mutate does is add or modify a column or a variable in our data frame. And remember, I'm going to use data frame and table very interchangeably because they are almost the same. Okay. So I'm going to add a new variable that's called quarter, just like this one. And I'm going to do case when. So case when needs a logical situation and a result. So if my values in a month are inside, this is what this in operator is telling, this vector. So basically, if month has January, February, or March, then put Q1. If it's April, May, June, Q2, and so forth. Now, you can give case when, like the if not. So the final if not, if it doesn't comply with any of these logic sentences that I've given it, what is it supposed to do? So if none of these say actually true, then I want an A. So this new table has a new variable, which is quarter. And if I do spending quarter, I'm gonna get the same thing that I have on Excel. Quarter one, quarter one, quarter one, and at the end, quarter four, quarter four, quarter four. Is that clear, guys?
Teacher, can you repeat the part of the line 20, please?
Line 20. Okay. So mutate, what it does is modify or add a new variable to your data frame. So that variable is going to be called quarter. Now, what am I going to put inside quarter? I'm going to use case when, which works like a nested if statement in Excel. So if month is January, February, and March, inside quarter, get me Q1. If it's April, May, and June, get me Q2, and so forth. Now, if it doesn't comply with any of these situations, put an A. Is that better?
Okay, so mutate is like creating, also modifying, but in this case, overwriting also, right?
And we didn't have any variable called quarter.
Ah, okay, okay, okay. Yeah,
So it's
okay,
creating in this case.
okay. Thank you.
Mhm. So the next one, the next example that we're going to do is pivot tables. So pivot tables are very used in Excel. We select the whole page and we can insert a pivot table. Now, what are we going to do with this pivot table? So for example, we could do what was I going to do? Total expenses and budget by expense type and quarter. So total expenses, which is my amount by the type of expense and the quarter. So amount by the type of expense and the quarter. Okay, so we get a general summary of how much we've spent on consulting each quarter and overall, and how much we've spent in lawsuit office happy hour. Now you can see clearly that this office really does go hard on happy hours, supplies, etc., and also the grand total. How do we replicate this behavior in R? So in R, we can use group by and summarize. So we have our spending quarter that we just created by adding the quarters. Now we are going to group by expense, which remember is consulting, lawsuits, office happy hour, and office supplies, and quarter. And we are going to summarize using these two groups the total of expenses, the total expense amount, and the total budget. Okay. So for example, in order to make it evenly, let's add the budget over here. So let's do it by parts. Okay, I'm going to span this out a little bit. So if I just do the group by, my data doesn't change. However, over here it's going to tell me that my groups are expense and quarter. And how many different combinations of these two values there are? 16. Okay, these are like my unique identifiers for my next operations. I'm going to summarize by adding a total expenses variable, a total expenses amount, and a total budget amount. And what all of these are going to do is, for example, the sum of number of expenses, this will be the count of expenses that we have, so the sum of this variable of number of expenses, and it's going to compute it 16 times because there are 16 unique combinations of expense and quarter. And we can confirm it over here. There's consulting Q1, consulting Q2, consulting Q3, consulting Q4, lawsuit Q1, lawsuits Q2, lawsuits Q3, and so on. And this point groups drop is basically saying that I want to not have all the groups anymore. So for example, I have consulting Q1, total expenses, consulting Q2, total expenses, and I have the total expenses amount and the total budget amount as well. Why I cannot see it? Because I need more space. For example, if I expand it a bit, I get the total expenses amount. And if I expanded it a bit more, then total budget amount. And hold on, I'm gonna teach you something new. So view allows you to open up a new window of your data. So with this, we can see our data when it's total. Now, you're not going to, you're probably going to use view a lot in order to check if the data is actually behaving you want it to be. But you can also print it in the console. Any question of this, guys? So group by and summarize are very powerful weapons in order to do this. Álvaro.
Sure. I have two questions. The first one, a
Sure.
spending table is just a script already created, right?
A spending table.
No, no, no. When you call it in the line for 45, it's already
Uh-huh.
been created.
Yeah, because I already assigned it over here in 36.
Ah, okay, okay. And the second was a summarize. What's the difference between a group by? Because group by, I understand that is like you put in groups, but summarize is more like you put.
So they work together. Basically, group by is telling the table that you want them to be, so for the following calculations, you want to do those calculations one time per group.
Yeah.
So with only giving it group by, you haven't done any type of calculations yet. You've only identified your groups. With
Okay.
summarize, you're going to summarize your data with those groups in mind. So this total expenses is going to calculate it 16 times because you defined that your groups are expense and quarter, and this gives you 16 different types of combinations in between these two.
For each group, they have all these kind of estimation, no? The sums of the
Mm-hmm.
non-spent.
So that's why on our final spending table we have 16 observations.
16. Okay. And when you point groups, you equal drop.
Oh, that I could have not put it if you want. Doesn't change after time. So if we view it again, exactly the same.
Okay, but you cannot call that kind of thing in the console. You have to put in another script. It's not possible.
Yeah, I could have rewritten it, but to keep it on the script, you you almost always want to keep stuff on the script because if you run something on the console and you forget it to put it on the script, once you deliver something, it won't.
Uh,
Nobody will know that you actually run something in the console.
it's erased. Yeah, yeah. Thank you.
Don't
Thank you.
worry.
Thank you.
And any other question, guys? Okay. All right. So let's keep going on. So for example, what we can do is to our pivot table, we could add a new variable. Now, if we have the budget and how much we spent, we can know how much money we have left. So for example, leftover. Now our leftover is basically the money that we had minus how much we spent. So we can know if we went over our budget or not. Oh yeah, I forgot about this thing. Hold on. C4. That's not. Oh, yeah, that is C4. And B4. There we go. So in general, we didn't go over budget for our whole operations. And even if our happy hour was really expensive, we didn't go over budget in our happy hour. However, we spent a lot of money in lawsuits on Q1 and Q2, and we did go a little bit overboard on our happy hours on Q3. Now, how can we do this in R? So for example, let me expand this a little bit. Remember that we talked with mutate. So mutate allows you to create or modify columns or variables in your data frame. So spending table, we're going to mutate it by adding a column named leftover that is just total budget amount minus total expense amount. And we are going to arrange it. Now, arranging, what it does is ordering by a specific variable. In this case, we're going to order it by leftover. So if we run this, we can see that what we've spent the most is on Q1 lawsuits, then in Q2 lawsuits, then our happy hour in Q3, etc. Now, for example, if we wanted to know, yeah, because right now we are, if we spend the most, that means that it's the lesser value, right? Because it's negative numbers. If you wanted to do from from the greatest number to the lowest. So in this case, the item that we spent the least, you could have done descending leftover. And the thing that we've spent the least is Office Q3. Let's keep it on what thing we spend the most. And don't worry. So lawsuits, happy hour, consulting, etc. And I think this is office supplies. No, this is again happy hour. Okay, so for example, if we wanted to know only on which quarter did we party the hardest on the office, we can filter by the expense type and say only we want to know office happy hour. By doing this, we can get that we spend the most on office happy hour Q3, then Q1, Q4, Q2. Obviously, we're not going to get the rest of the items because we're filtering them out. Okay, so if we wanted, for example, to view this, remember, by using the pipe operator, we can give it more functions. So view, for example, and we get the whole data frame over here. Also, we can confirm that this is the lowest value and this is the highest. Okay. Now we're going to move on to a different data set. Gonna move on to the superheroes data set. Let's shift this a little bit. There we go. To have a little bit more space for our. Okay. So first of all, let's do it in Excel. So let's see what data we have. So we have a different set of heroes: Superman, Batman, etc. In which universe they are, DC or Marvel, if they have powers or not. This is arguable. Batman has the power of money, and when they first appear in a comic book. On the second column, on the second sheet, we have their real names. So for example, Superman is Clark Kent. Now, is it secret? So does everybody know that Clark Kent is Superman? Yes, it is secret. Those glasses are clearly very deceptive. So, for example, Black Widow doesn't keep it secret because basically her name is her agent name and she's a secret agent. Nobody knows about it. Captain America doesn't keep it secret because he was a military project and everyone knows the story. Okay. Which powers each superhero has? So, for example, again, Batman, it's arguable that he has the power of money. And the occupation, aside being a superhero, of their real name. So, Clark Kent is a reporter, Bruce Wayne is the CEO of Wayne Tech, etc. Now, if we wanted, we could bring some information from the other sheets to the main sheet. Okay? So for example, if we wanted to know the alter ego Superman, we could use the function VLOOKUP. We want to look up Superman in which array in the array of superheroes. The column index is column 2. And I done goofed. Superman in the column index on 2. Oh, do I have to give it a range? Yep. Clark Kent. And we can do this for them. Now, for example, not all of them have actual matches on our alter ego list. Why do they not have matches? Because one, for example, Miss Marvel is an alien, so she doesn't have an alter ego on Earth. Ironheart is created, so he doesn't have an alter ego either. Black Lightning, I don't know, maybe this data set is a little bit racist because Black Lightning does have an alter ego. He was a policeman. And he has a really nice series that you guys should see. I think no, it's not from Netflix. Don't quote me on that. I don't know if it's on Netflix, but it's a really good series. But now we have the data for their alter egos. Let's try to do the same thing on R. So on R, we've already learned how to read Excel files. We just do read Excel. We take the path, but on this case, we have an Excel workbook with multiple sheets. So we have to specify the sheet ID, in this case, heroes and alter egos. So I'm gonna clean up my environment so it's a little bit tidier. Let me give this a little bit more space. Okay. So I have my superheroes database and I have my identities database, which is basically my alter egos. Now, just like I had VLOOKUP on R, what I'm going to use is left join. So with my superheroes database, I'm gonna left join it by my database identities. And what is my identificator? Or what is going to look on both data frames in order to join them? What does it have in common? Now, both of them have the variable hero. So it's going to use the variable hero in order to join them. So if I do hero identities view, I now have that Superman is Clark Kent, Batman is Bruce Wayne, and also it joined the is secret yes or no. It joined fully both data frames. Any question? Okay, I guess we're good. Now we can do the same with the powers. So let's add the powers that each superhero have to the main data frame. So let's load it up. We can see that powers is Superman, flight, man, he's super rich, etc. And also let's load up occupation. Occupation, remember, is what they do on their day job. So Heroes Fall will be my superhero identities in which I already joined the identities. I'm gonna join the powers by hero, but notice something in the occupation, I don't have hero anymore. I have name. And on no other database, I have a variable named name. However, the name is basically their real name, which is in my alter egos database, alter ego. So I want to say that on the data frame that it's on the left, so superheroes identities, alter ego means name on the data frame on the right that I'm going to join by. So by doing this, I'm gonna get my all heroes database. So if I want to know something about Superman, I can know in which universe he is from, if he has powers, when did he first appear, what is his real name, is it secret or not, what is his power, and what is his day occupation. Now there's one final function. So basically you can say that once we get to have a lot of variables, our console window gets very crowded. In order to avoid that, we can summarize even further our data. Now, function similar to structure is glimpse. So glimpse allows us to see the number of variables that we have, how many observations, and which are the variables and what kind of variables they are. So characters, character. This DTTTM is date, time per minute. So it's a broader sense of time, and then characters. And that is generally it, guys. Do you have any question, Álvaro?
Yes, what do you put a percentage, for example, in line 777? A
What did I
percentage,
what?
porcentaje final, percent, in the
Which one?
superheroes identities,
Uh-huh.
percent, major percent.
The
And
pipe
why?
operator.
Uh, why?
So the pipe operator, like we said before, also called a Magritte operator, what it's doing is it's using the data on its left to apply it to the function on the right. So it allows you for a more readable code. So it is actually more readable. So for example, we want to join, we want to take the superhero identities data set and join it with the powers data set by the name of their heroes. Then join that result with the occupations data set by alter ego. That it's a name alter ego on the data set on the right and named name on the data set on the left and then named name on the data set on the right. In this case, it's quite easier, right? Heroes full, we want to apply the function view.
So it takes like the column in the right, whatever the column was before. It always
So
takes.
it takes the object on the left and applies it to the function on the right.
Okay, yeah, thank you.
So yeah, guys, that's generally it. Does anyone have any further questions? Well, I guess not. Then I won't be taking more time from your Saturday. I hope you guys learned something today, and we are probably going to use this pipe operator a lot. So if you have any doubts, please reach me, and we can get it sorted out. And yeah, have a good weekend. Tell me, Alvaro.
When you put that operator that we talked recently, you have to put in the other line to concatenate, something like that. You have to make an
No,
space.
I could have put it in the same line. It's just for order.
Okay. But
Yeah.
left join also you have to put it or not? Was not necessary.
No, left join is the function that we are using to join the both data frames.
But you don't have to use. You can put I don't know power and that's all or
Yeah,
not.
we could have used any function, but in order to join the data frames, you were using left join.
Uh, and you can put power like nothing, and that's all, or it's bad if I put power so.
So in this case,
Uh,
it it won't be able to. I don't know if it's able to get the identifier by itself. So it tries to be smart about it. I don't know if it's that smart.
okay.
Oh, it is.
But if,
It is that
mhm,
smart. So if you see over here, it says joining by hero because it identified that two of the variables on both data frames are named the same.
mhm.
If I were you, I always try to identify which is the variable that I want to join by.
Okay, so if I want to put that power and I don't put left joint, it will send me an error. No, it's like necessary.
So if you just do this, that's what you mean?
Uh-huh.
Oh yeah,
Uh,
definitely.
okay, okay. And when you talk about by row, you mean that kind when we talk about by row
By
that
row on matrices.
yeah, it's you are counting by row. That's that what it means, or it means another thing when you talk
So
about
over here on matrices, that's what you meant?
yeah. When we talk about by row, you
Yeah.
mentioned
All
that.
this. So when we're talking about by row, it's that when you have the data,
Uh-huh.
you're you if you use by row, first of all, you need to use n row. And when you use n row, you're telling R how many rows your data should have. And by using by row, you're telling R by using that many rows that I have given you, calculate how many columns you need to use by yourself.
Okay. If it's three, count one, two, three, and then the other row, four, five, six, and then the rest, right?
So it's basically you give it 3 rows, and
Uh-huh.
since your data has 9 data points, you
Uh-huh.
divide 9 by 3, so you're gonna get 3 columns as well.
And if you put two rows, what is going to happen?
If I put
Like
what?
two rows.
If I
Two.
put 2 rows, it probably won't compute. Yeah, error. Well,
Uh,
it's not giving me an error, it's giving me a warning. Because it's not using one of the data points that I have given it. It's only using 8, and I gave it 9. So it's omitting
uh,
one value.
I'm repeating like one, right? In the nine in the five column, like you said.
It's correct. Yes.
Okay, yeah. Thank you, teacher. Thank you very much. Goodbye.
No problem. All right. Does anybody have any further questions? Very well. I will upload this now so I don't forget. And yeah, have a great weekend, guys. I won't take more time from you guys. See ya.